Welcome to the operator overloading session in classes and OOPS module. So let us move on to another important concept in OOPS, which is operator overloading. So operator overloading simply means intercepting built-in operations in class methods. So Python automatically invokes your methods when instances of the class appear in built-in operations, and your method's return value becomes the result of the corresponding operation. So here is a review of the key ideas behind overloading. The first one is operator overloading lets classes intercept normal Python operations. In a simplest way to speak, it is like customizing the way it is showing the results. For example, if you want to print something, okay, when you show your object, you want to print in a certain way, not the default way, not the default display way. You want a different display. So in that case, you have to use another method to get your get your customized display. So like that, you can actually overload the existing methods to do the customization. And second, classes can overload all Python expression operators, any Python expression operators. Then classes can also overload built-in operations such as printing, function calls, attribute access. Just now we have discussed printing display operation. So for example, if you want to have a customized display, then you have to use str or repr, either of these methods, to have a customized display. And basically this customized, this str or repr, these two methods will overload the existing default printing display method, and it will give you your customized display whichever way you want. I will I will explain this with a proper example, so you don't need to worry, you just follow the concept for now. Then overloading makes class instances act more like built-in types. Overloading is implemented by providing specially named class methods. We'll see what are those. All overloading methods have names that start and end with two underscores to keep them distinct from other names you define in your classes. Okay, if you remember the namespace of various objects, it must consist of a capital, the global scope on top, and then in between we must have seen double underscore names, and below which lower case names. You just now try to connect what is the double underscore names in that namespace. Now, if you take an example, the name trailing double underscore add leading double underscore always maps to plus expressions by Python language definition, regardless of what an trailing double underscore add double underscore methods code actually does. So now, however, as a fact of matter, operator overloading methods are never required. Yes, and generally don't have defaults. If you don't code or inherit one, it just means that your class does not support the corresponding operation when used, though these methods allow classes to emulate the interfaces of built-in objects and so appear more consistent. So now we will see what are those methods. We'll see some of the examples. There are plenty of methods, but we'll see the most widely used examples. Okay, so first one is init, and then del is a descriptor, and add operator is for the addition, and then or is for the logic or bitwise or, and then repr or str, these are for the printing and conversions. We have just discussed that example. If you want to customize your default display format, then you should go for this repr or str. Then we have call. Call is to customize your function calls. Then get is to fetch it so that you can use it in indexing. Set iter, it is for the attribute assignment. Then we have more to see. First one is get item. This is particularly for slicing and iteration. To customize those operations. See, when you go for iteration using for loop, you will get a specific default format. That first item, second item, third item, fourth item in line by line. Okay, if you want to customize that format, and it should be applied to each and every instance that we create, then what we'll do, we will create another class and we will apply it to each and every instance so that it can be applied to every instance of that class. Similarly, set item, index and slice assignment. Then del item to delete these items, and len is for length, we all know. Bool is for boolean tests. Lt, gt, these are for comparisons. Less than, gt greater than, le less than or equals to, ge greater than or equals to, eq equal to, ne not equal to, right side operators. And iter, at least you should have remembered this one, iter. And next we have used this to create a manual iteration. Okay, so but under the hood, these are the things actually work. I will show you in while we code on Jupyter notebook. Okay, and contains, this is for the membership operator. For in is our membership operator na, so contains is for the membership test. And index, enter, exit, get, set, delete. And finally new is for the creation. So now what we will do, we will go into a folder, so operator overloading, and here I will open my VS Code, and let's create a class, a number class. So this number class consists of two methods. One is init, second one is sub. Basically, and init is as a constructor, it takes one argument, and then this argument or parameter is assigned to self.start. Now this self.start. Then we have one more, that's the subtract sub as a method, but this one returns an object. This one returns an object of number class after doing subtraction of whatever argument you have given to that method and an instance attribute. Okay, now let's save this, and then we'll go to the same folder and open Jupyter notebook. In that directory, let me open this. Yes, it's taking a bit of time to open. Yes, it's ready. So pretty slow. let's give enough time to it. Okay, let's begin now. So first we'll see the same example. It's a number class and we have saved that file with small n, the lowercase number.py. So to access that we have to call it using this number, but the motto here is it provides a method to intercept instance construction as well as one for catching subtraction expressions. Special methods such as these are the hooks that let you tie into the built-in operations. So we have import number module. We have from that number module we have imported number class, you can see. So first I have created a number. Okay, just execute this. So now I have created a number object. The first object I have instantiated an object, and then when I use x and minus 2, automatically I'm getting another object. So this is how we use a subtraction method to create another object and overload the constructor. Here what we are doing is we have overloaded the constructor using sub. Basically we are incorporating a subtraction operation into constructor also. Okay, then we will move on to next example, that is get item and set item. So this is basically of indexing type. So here for instance indexing operations, when an instance x appears in an indexing operation or expression like x of I, Python calls the get item method inherited by the instance, passing x to the first argument and the index in brackets to the second argument. So that's what happens here. We'll take one example. Indexer is our class and get item is the method we have used here, and then self comma index is our. So now whatever parameter we have mentioned here, so that power square we will get it. Now the thing is we will instantiate one object. Okay, so x is equals to indexer. So this is our object. Let me, okay, first I have to, now what I will do is now I am using this to get. So as per this, now it is overloading the default constructor. Now here we haven't given anything, so we have just created an object. Now after that, when I give this index of 2, so basically it is taking this as 2 and then this value 2, and then it is giving the power of that 2. And similarly if you see here, this is an example, the same example for I in a range, and we have used the same object and then we got the squares of it. Then intercepting the slices. Intercepting the slices, we used again get item. So formally speaking, built-in type handles slicing the same way here. For example, slicing at work on built-in list using upper and lower bounds spheride. So this is one example. So get item we have used, get item method we have used, and then whenever and after that what we have done is we have created an object, we have instantiated an object, and then whenever you call this x of 0, it will give you a print this way. So get item 0 and 1 minus 1 2 to 4. So a proper way it is giving your values, and then finally slice. So next we'll move on to memberships, that contains iter and get item. These are very important. So an iteration using either the iter method or the get item method to support more specific membership. Though classes may code a contains method when present, this method is preferred over iter, which is preferred over get item, and the contains method should define membership as applying to keys of a mapping and as a search for the sequences. Let me take one example, then it will be much clear. So here consider the following class which codes all three methods and tests membership and various iteration contexts applied to an instance. Its methods print trace messages when called. Okay, let us see. What is the name of the class? Iter. Then constructor will take one argument, that is value, and this value is connected with self dot data, which is instance variable. So now we have used around four methods in it. The first one is get item. Get item, we have used I argument, a special argument, and then we want to print this way. Okay. Now from where it should get? From the self dot data I. So this is I's index. That means whatever list that you give it to your object, then from there it will fetches whichever item you want. So this is how you actually code your indexing, your index behind the hood, under the hood. Okay, so basically this gets your index and slice. And second one is for the iteration, you use self.ix is equal to 0 and return self. And third one is for the next, to stepping into next stage. Once everything is done, if you see this step self.exe, you do it until the end of the, until it is equal to length of that list or whichever sequence you have provided. Once it is done, then erase a stop iteration error. Then append all these into the list. Then finally a membership operator. To make a membership operator, that's a contents, and print this return x in self dot data. So let's see, let's execute this and then we'll see. Okay, first we will see the operator overloading, and then we will discuss how a default thing works, and we can see, we can compare both. So then it will be much clearer for you. It makes a clear picture. So here I have taken example. So I have made an instance that is x, name of the instance is x, and then iter is our class name, and then inside that I have given a sequence, a list. Okay, a list I have given. Now first we will check the membership overloading, that is print 3 in x. Then we will use for loop to do rest all stuff, but for us we will focus on this membership. What we got here is print 3 in x. Oh, just a minute. So basically what we are doing here is we are customizing the way it looks. So now when I execute print 3 in x, so I got 3, it contains x, it is true. Whereas if I use a default one, 5 in 3 4 8 list, I'm just getting, okay, There is no other option to restart. What I got is false, just a false. But here I got contains true. To make this possible, to customize your existing methods or functions or operators, we use operator overloading. Whatever default method is there, we will use these methods and we will code the way we want, and we will overload that and we'll get a customized piece of result from the same type. So now I think with this it will be very clearer. You'll get a clear picture from this. Okay, from rep and the str. These are the two methods. This example exercise is the init constructor and then add overload method, both of which we have already seen, as well as defining a rep method that returns a string representation for instances. So string formatting is used to convert the managed self.data object to a string. Clear? And then if defined, rep is called automatically when class instances are printed or converted or strings. These methods allow you to define, this is important for you. These methods allow you to define a better display format for your objects than the default instance display. Okay, let's check. Let's check one example. Then the default display of instance object is neither useful nor pretty. Why? We will see. We have created an adder class and this is our blueprint. In that blueprint, what we have written is, first is init constructor with value 0, and then this value parameter we have assigned it to self.data, that is instance attribute. Then we have used add a method and we have done some operation, but that is not important for us here. What is important for us is here, when after making an object, then I printed this. Let's see what we'll get. What we got is this main.adder object at memory location with hexadecimal number. Can you make anything out of it? Are you able to understand something out of it? I can understand what adder is an object of main class at this location, but for people who are not, if the people are just users who are not techies, then for them who are not coders or programmers, for them it is difficult to understand. So now what I want is, I want a better way to display the same. So for that, what I will do is, I will use a operator overloader. What is that operator overloader? Trailing double underscore REPR leading double underscore. That's what I will use. So here what I have done, I have created one more class, add repr, with a super class adder that we have coded on top, and it actually inherits the init and add both. Now repr method I have used in it. In that I have written the way I want to be displayed. So let me execute this. So now I will create an object and then I'll see what is the method. You see here, add repr 3, but when I type x here, so sorry, now because here it changes. Okay, now what I'll do, I will execute this again, this piece of code. See now when I run that x object, I got this display format. And now after using operator overloader, that is a rep operator overloader, what I got is this. So now which makes more sense, which is more intuitive. So that's how we can customize display format, loop format, membership format, iteration format, everything. It is not just displaying, it is the operation also. We can we can customize anything and everything. So now, for example, this is one for x in this sequence I have given list, and let's execute this. So this is the way I get. So even that can also be customized. So here I got it in a different way. Print 3 in x, but I used in membership only. So if you see here 5 in 3 comma 4 comma 8, I used in membership only, I just got false. But here 3 in x, I used the same thing, almost same piece of code, but x is an object, and that object consists of a method, certain contains method which has defined how to print it, how to show it. So now it has given me a proper way. Yes, S3 contains true. So that's how, that's beneficial it is. Okay. Now, so why to display methods? So why to display methods? Mostly to support different audiences. So in full detail, str is tried first for the print operation, and the str built-in function is generally should return a user-friendly display. Ripper is used in all other contexts. For interactive echoes, the ripper function and nested appearances, as well as by print and str. So it should generally return an as code string that could be used to recreate the object or a detailed display for developers. So with this, you're able to understand what is an operator overloading. But if you remember these names like trailing double underscore, add leading double underscore, you have seen somewhere else, I guess. Okay, I'll just show you where we have seen. So I'll go to the command prompt first for that. So here is my command prompt. You just look on top. So pi. So now I will dir list, and we'll see what we get. What we got is a namespace of list. A namespace of list. And what does this namespace consist of? If you see this, all double underscore add double underscore class get item contains dill letter dill item dir doc equal format greater than get attribute get item gt greater than hash add init iter less than or equal to length less than not equal to new reduce ripper just we have used. So after once you are the str set item, then once you are done with these double underscore names, we have a lowercase names. Basically these lowercase names are methods. But what are those double underscore names? Double underscore names are inbuilt functions or methods. So to run your methods, for example, append clear list dot pop. What is this? This is a method. So list dot. So what is this? This is a slot wrapper add of list object. So basically, whatever your methods which are related to your object are running. See, if you see list.pop, what is that? Method pop of list objects. So list is an object. a class or an object, and pop is a method of it. So now to run these methods, you need some backend support. It should be coded with somewhere. Na? So these are those methods. Using the double underscore wrappers, using these wrappers, we have created these different methods. Now to these methods to be run properly, you need, see, we have less than or equals to operation, greater than or equals to operation. So to run all these operations, these all should be built using these things, double underscores. So now to do overloading, to do operator overloading, we use the same methods. We use the same methods using classes. We create a class, and we add these methods, and then we create a customized way of doing those operation, and then we will call that class in our program, and we will get the customized way of doing those operations. I hope you got more clarification and clarity with this uh, example. So with this, I'm closing this session, and I will be seeing you in next session, more interesting, a much more interesting session. Just keep watching my videos and keep subscribing it and keep liking it and keep spreading the word to your friends so that everybody can get benefit out of it. Thank you and see you again.